Hello everyone. Let's discuss laws of osmotic pressure, Van 't Hoff general solution equation and the relation between osmotic pressure and molar mass of the solute. Let us begin with laws of osmotic pressure first. When we talk about the laws of osmotic pressure, then the gas laws are applicable over here. Then why gas laws are applicable over here in case of solution? Now, here in colligative property we precisely study dilute solution, and the solute particles are in a state of random motion, and such a behavior is very similar to that of the gases, and hence we'll study all the gas laws with respect to solution. The first one is Boyle's law, which states that at constant temperature the pressure is inversely proportional to volume, that is for 1 mole of gas, and this is for gases. Now for solution, the modification is first of all the name itself. First of all, the name will be Van 't Hoff Boyle's law, where P will be replaced by pi and 1 mole of gas will be replaced by 1 mole of solute. Above that, I can also say that concentration is inversely proportional to volume. So I can say C is inversely proportional to V. And here from this equation, 1 upon V can be easily replaced by C. So I can say 1 pi is inversely proportional to V, and second pi is directly proportional to C. And hence the statement is, it states that at constant temperature, the osmotic pressure of dilute solution is inversely proportional to the volume of the solution or directly proportional to the concentration of the solution. Let's see the second one, that is called as the Charles law. Charles law at constant volume, it says that at constant volume pressure P is directly proportional to temperature, and that is also applicable for 1 mole of gas. Now the modification is one name itself, that is called as Van 't Hoff Charles law, where P is replaced by pi and 1 mole of gas becomes 1 mole of solute, and the statement is this. It states that at constant volume the osmotic pressure of a dilute solution is directly proportional to the absolute temperature of the solution, and that's Van 't Hoff Charles law. Since we know now what exactly is Van 't Hoff Boyle's law and what exactly is Van 't Hoff Charles law, let's go ahead with the Van 't Hoff general solution equation. Van 't Hoff Boyle's law says that pi is inversely proportional to V, and Van 't Hoff Charles law says that pi is directly proportional to T. So I can say that pi is actually directly proportional to T upon V. Now to remove that proportionality sign, I have to introduce a constant, and I can say pi is equals to K T upon V, where K is a general solution constant. Above all, when I say pi is equals to K T upon V, I'll just rearrange to get what? Pi V is equals to KT. When I say pi V is equals to KT, this is called as a Van 't Hoff general solution equation. Now the observation of this equation is that the value of K is equal to the value of universal gas constant, that is R is equals to 8.314, that R is a universal gas constant. Hence I can say pi V is equals to RT. I am just replacing that K by R. Correct? So pi V is equals to RT. Now this is applicable for 1 mole of the solute. For n mole of the solute, I will have the equation pi V is equals to nRT, that is for n mole of solute. Further, I can say that I'll just rearrange once again to get what? Pi is equals to n upon V RT, where n upon V is nothing but concentration. So I can say it's pi is equals to CRT. Having this equation, that is pi V is equals to nRT and pi is equals to CRT, let's go to the third law of osmotic pressure, that is Van 't Hoff Avogadro's law. Now for Van 't Hoff Avogadro's law, I'll use the equation pi V is equals to nRT, and for two solutions I can easily say the equation will be pi 1 V1 is equals to n1 RT1 and pi 2 V2 is equals to n2 RT2. Now I am going to divide this both equations. So what do I get? Pi 1 V1 upon pi 2 V2 is equals to n1 T1 upon n2 T2. My first condition is that, okay, what is going to happen under similar conditions of temperature, where T1 is equals to T2, then I can say the equation becomes pi 1 V1 upon pi 2 V2 is equals to n1 upon n2. Second one, I'll say that the solutions have equal volume, so V1 is equals to V2, and when V1 is equals to V2, the equation becomes what? Pi 1 upon pi 2 is equals to N1 upon N2, and I say further that they are going to exert the same osmotic pressure, that is pi 1 is equals to pi 2, so what it remains? It is going to conclude N1 is equals to N2, they contain equal number of moles of solute in the solution, and that's the statement of Van't Hoff Avogadro's law, which states that under the similar conditions of temperature, equal volume of two solutions exerting similar osmotic pressure contains equal number of moles of solute in the solution. Let's see the next one, that is nothing but the relationship between molar mass and osmotic pressure. We know the equation pi V is equals to N2 RT, where N2 is nothing but the number of moles of solute, which can be written as W2 upon MW2. I can say that pi is equals to N2 upon V RT, where I said that N2 is nothing but what? W2 upon MW2 RT. From here, let me rearrange to get MW2. What do I get? MW2 is equals to W2 RT upon pi V, and that's the relationship between molar mass of the solute and the osmotic pressure. That's all we have for this particular module. Thank you so much.